Hello and welcome to my demonstration video for my elevator 3. Things have gotten progressively more complicated as we moved on. Now, this is the same elevator setup as last time, except now the code has memory. It's no longer working as a freight elevator. So we still have a stepper motor and a servo. We have 8 push buttons acting for each floor, and a light to represent where you're at on each floor. Whenever you press a button, it'll light up and it'll go there. But once it reaches its destination, it'll start to wait for 3 seconds, waiting to see if it gets any inputs. And so if I were to press these two buttons at the same time, both lights would go on, and the elevator would resolve them in order. And so it would go to this floor first, it'd open the door and close, and then it'd go to the top floor, open the door and close. And now you can actually press all 8 buttons at the exact same time, and they'll all come on, and it'll start resolving them in order from top to bottom. And obviously when you get to the first floor, it resolves both of these at the exact same time. And so this will just go from the top, or from the bottom to the top, and that's how it works.
We will now begin the code walk for my elevator 3. Things have gotten a little bit more difficult since our last iteration. Starting at the top, we have button state equals 0. That starts the buttons at low. Includes servo H, includes the commands for the servo. Same with include neopixels, includes the commands for the neopixels. This piece of code is setting what pin the neopixels are attached to. It's 19. Includes stepper.h, includes the stepper commands. Steppers per revolution sets how many revolutions it will make whenever it's called. This is setting the pins that the stepper motor is attached to. This names one of our servos door for later purposes. We have replaced a few of the variables, fcall and ecall specifically, with j. This will be brought up in a moment, but our variables are I and j. Floor push buttons are on 8, 9, 10, and 11. And our elevator push buttons are on 2, 3, 4, and 5. And what we replaced fcall and ecall with is flist. This is a list of numbers, 1 and 0, and dependent on what numbers are in the list is dependent on where it should go when it's called. And this unsigned long time is a variable that will be used to set our timer. In our setup, we have lights begin. We attach the door to 13. We set the lift speed to 20. We make sure that the door starts at 0. And we have our algorithm that will tell the elevator how far to move when a button is pushed. That is used for 2 plus I and 8 plus I for our floor and elevator push buttons. Starting in our loop, we have get flist, which calls the flist to see what numbers are in the list to see what button was pushed. We have our algorithm that'll tell the elevator where to go. If one of the flist is equal to 1, meaning it's set to high, the elevator will go to that floor. The door will open to let people in. The light will turn off. It'll show that it did that. And I have it in here twice to make sure that the right lights turn off. It will then get flist again to look for more signals before closing the door and setting flist to 0 to allow it to move again. Now that our loop is closed, we have get flist. This is how the elevator will move. This sets time equal to millis, and this piece of code is what we use to time our elevator. It'll wait for 3 seconds to allow for inputs, and then after that 3 seconds has elapsed, it will move to its next destination, and then wait another 3 seconds to wait for inputs. This is the same algorithm as above, but for variable j. If j is equal to low for our E push buttons, it will set flist to 1. It will move to that location, and it will set the light to high to show that it's there. It will do the same for the floor push buttons here. You can do these both at the same time as long as it is waiting for inputs, and it will hold a memory of what buttons have been pushed and resolve them in the order that they are in. And that is the basic rundown of the code.